Alright, so this video is going to go through the objective of using properties of quadratics in various contexts. And that's a pretty vague objective, just so you know what we're going to be doing today. The property that we are talking about is going to be symmetry. Alright, so the idea that each half of a quadratic is the same on either side, mirror image. And the context we're going to be doing in this video is just graphing. So there will be others, of course, but for now, this will be it. So we're going to graph these the way that we have been doing so far, starting with a vertex at 3, 6. So I'm going to plot that as right 3 and up 6. And I will just put a big dot right there. Then it says there's an axis of symmetry at x equals 3. That's not really a surprise because the x value of the vertex always is the same as the x value of the axis of symmetry. So here is a vertical line going down, so that's going to be that's going to give me the two mirror images on either side of this. And then finally, we've got our additional point at 7, 10. Now this is going to be the one that we really need. So 7, 10 over 7 up 10 is way up here. Now we know parabolas are U-shaped, and since the vertex is either a maximum or a minimum, it looks like this is going to be a minimum and probably look like that. And although you can probably just eyeball it, I'm going to count, since this additional point is 1, 2, 3, 4 spaces to the right. That means it has a mirror image point 1, 2, 3, 4 spaces to the left. Since this point is 7, 10, that means this point is negative 1, 10. Equidistant from the axis of symmetry. Once we get those points, we're basically done. We're just going to draw in our parabola. Sorry, it's not super neat, but you get the idea. Let's do this one more time. Vertex at negative 8, 1. So I will start by putting that point there. Negative 8, 1 is left 8 up 1. We've got our axis of symmetry at x equals negative 8. Again, same x value always as the x value of the vertex, except this is the line, the vertical line, x equals negative 8. And then our our additional point is at negative 10, negative 5. So that's left 10, down 5. And I can see this is going to be a downward opening parabola. And you can count right here. This point, 10, negative 5, negative 10, negative 5. This point is 2 to the left of the axis of symmetry, so it must have a mirror image 2 to the right of the axis of symmetry. That point is at negative 6, negative 5. The y value is the same. And then I can draw on the parabola. And I drew my line to the end, or you could have drawn arrows at the side to show that it keeps going. And that is it. So we have used the property of symmetry to graph quadratic functions. So graph some parabolas.